So we're going to talk about the graph of an exponential function. So here we have a basic rational function, I'm sorry, exponential function. So they don't get much simpler than this. We're going to make a little table of values here. So x and f of x, and we'll see what happens. So let's put in 0, 1, and 2. And we'll go ahead and put in 3 and see what happens. So we're saying 2 to the 0 power. Well, 2 to the 0, you have to remember what that is. You have to remember your exponent rules and stuff. 2 to the 0 is 1. Okay, what's 2 to the first power? 2. What's 2 squared? 4. What's 2 cubed? 8. Okay, so we can graph those points. 0, 1, 1, 2, 2, 4, and 3, 8. See how it's going up very quickly? Okay. Well, that tells us what's happening to the right of 0. But remember, x is any real number. What happens if x is negative? So what if I had a negative 1? Well, what's 2 to the negative 1? Again, you have to remember about your exponent rules. So go back and review exponent rules. But a negative exponent is 1 over 2. Remember, it's all about location. So 1/2. Okay, a negative exponent makes it reciprocal. There's a little exponent rule that says b to the negative n equals 1 over b to the n. Okay, that's what we're working with here. So what happens if x is negative 2? Well, then you're going to get 1 over 2 squared, which is 1/4. And then if I put in negative 3, I'd get 1/8. Those are going to get hard to graph. Okay, so I mean, if you put in negative 3, you would have 1/8. I can scroll this up a little bit. Okay, but like I said, you're getting smaller and smaller, right? So where's negative 1 1/2? Right there. Okay, so this point I graphed, and then below that, and then below that. You can't even, really distinguish them here. Okay, so the graph goes like this. Now, would I ever get an output of 0? No, because you're not, you can put in numbers all day for that exponent, but you're not going to get 0. And am I ever going to get a negative output? No, because 2 to some exponent's not going to be negative. Okay, so this is what the graph looks like right here. Okay, now I wanted to talk about, I provided another grid here, more about the graphs. So I think you have another thing on your note page that says more about graphs or something like that. What if you had g of x equals 3 to the x, 3 to the x power? What happens to the table of values? So now my base has changed. It's still a real number. It's still greater than 0, and it's not 1, so it can be 3. But what is, if I put in like negative 2 and negative 1 and 0 and 1 and 2, what happens? Well, when I put in negative 2, I'm going to get 1/9. So you can think about that, 3 to the negative 2, but you're going to get 1/9. If I put in negative 1, I'm going to get 1/3. If I put in 3 to the 0 power, I'm going to get 1. Okay, that's, still true. If I put in 1, I'm going to get 3. And if I put in 2, I'm going to get 9. Okay, so when I graph that, negative 2, 1/9. Okay, so it's really close to the x-axis. Negative 1, 1/3. Okay, 0, 1, and then 1, 3, and then 2, 9. So it's going up quicker, and it's going down quicker. Okay, so like when your numbers are positive, when your values here are positive, it's going up quicker than when the base was 2. But when it's negative, it's I don't want to say it's decreasing because we're going the other way, but it's those values as x approaches negative infinity, they're getting closer to the x-axis quicker. Okay, so I don't even know if I put these, you can look at the two graphs and kind of compare them, but they're both going through this point. That point they have in common, 0, 1. But this, this graph is going up quicker, so it would go above, and then this part's actually coming down down quicker like that, like it's below the other graph. They kind of cross. Okay. They show that in the textbook as well, and we'll talk about it in another video. But